Hey everyone, and welcome back to the Deep Dive. Today we are diving into some really cool research
Oh, yeah.
that could seriously change the future of electronics. Imagine,
Like
like
what?
all of our devices,
Okay.
but even smaller and even more powerful.
Wow.
And get this,
Yeah.
it's all thanks to tiny spheres of pure gold.
Pure gold. That sounds pretty fancy.
I know, right? But it's not just about looking luxurious.
Okay.
This is about solving a really big problem
I'm listening.
for engineers who are trying to make electronics smaller and smaller.
Oh, yeah. I've heard about that.
It's getting harder and harder to make those teeny tiny connections and not cause short circuits.
Yeah, that makes sense.
It's like trying to thread a needle in the dark.
Uh-huh. I could see that.
So how do these gold microspheres come into play?
Hmm.
Well, our deep dive today is based on a really cool article
Oh,
from the Hefei Institutes of Physical Science.
okay.
It's titled, Chinese Researchers Solve Key Electronics Challenge with Pure Gold Microspheres.
Got it.
And let me tell you,
Yeah.
it's a game changer. It was published just a few days ago.
Oh, wow. Very recent.
But this isn't the first time people have tried to solve this problem.
Really?
The article actually mentions a development
Yeah.
back in 2014
Okay.
by a Japanese company.
Yeah.
They were using something called array ACF
Array ACF.
with these things called metal-coated polymer microspheres.
That's a mouthful.
Basically, tiny spheres with a metal coating to connect things.
So what was wrong with those?
Well, imagine you're bending a wire that's coated in plastic.
Okay.
The plastic might crack, right?
Yeah, I get it.
That was the issue with those spheres.
Oh, so the metal coating would crack.
Exactly. That bond between the metal and the polymer was prone to cracking under pressure.
And we're talking about really, really tiny parts here.
Right, even the tiniest problem can cause big performance issues.
So how did the researchers at Hefei fix this?
Well, they went with pure gold.
Interesting.
Think of gold like Play-Doh.
Okay.
You can bend and stretch it without breaking it. Perfect for those delicate connections that are constantly under stress.
Clever.
So how do they actually make these gold microspheres?
Yeah, how do they do that?
Well, the article uses some pretty complex terms.
Like what?
Something called a positioned self-assembly and laser irradiated ropening strategy.
Wow, that sounds complicated.
I know, right? Like something out of Star Trek.
Haha, so break it down for me.
Well, imagine a super precise laser,
Okay.
almost like a microscopic 3D printer,
Cool.
but instead of plastic,
Yeah.
it's melting and fusing layers of gold.
Oh, wow.
And through this,
Yeah.
they can control the size and position of each microsphere.
And why is that so important?
Well, think about it.
Okay.
They need these microspheres to fit perfectly with all the other manufacturing processes.
Ah, that makes sense.
It's like they're making a universal adapter for electronics.
Oh, I like that.
So they're not just creating a cool science experiment.
Uh-huh.
They're really thinking about practical applications.
So what applications are we talking about?
Well, the article highlights one that's super interesting.
Yeah.
Microdisplays.
Microdisplays, what are those?
Think about your phone screen or like a VR headset.
Okay.
Now imagine those, but even sharper and more vibrant.
Oh, wow.
That's the potential we're talking about.
Oh, wait, so these tiny spheres can make our screens better.
Yeah, they can improve the bonding of the little components that make up high-resolution displays.
Huh. And what are those tiny components called?
They're called Model-D chips.
MOLED chips.
Yeah, and they're crucial for creating those amazing detailed displays.
Okay, but back up for a second.
Sure.
What exactly are these metal D chips?
Think of them like
Okay.
the building blocks of a super high-definition TV,
Okay.
but shrunk down to a microscopic level.
Wow.
They're super small light-emitting diodes that can be packed really close together.
Wow.
This lets you get a way higher resolution and more vibrant colors.
So better than LCD or OLED.
Much better.
Got it.
So by using these gold microspheres to make better connections between these tiny LED chips, we're talking about a whole new level of clarity and brilliance.
That's amazing.
And what's even more amazing
What?
is how fast they can make these gold microsphere arrays.
How fast?
According to the article, it takes just 1 minute.
1 minute?
I know, right?
That's crazy fast.
Totally blows traditional manufacturing times out of the water.
So is gold the only material they can use for this?
That's a great question.
I know, right?
And it leads us to one of the potential challenges with this technology.
Oh, what's that? Gold is amazing.
Yeah.
It's flexible and it's super conductive, but it's expensive.
Right, because it's a precious metal.
Exactly.
So using it for everything could get pretty pricey.
Especially if they want to make a ton of these things.
Yeah, are researchers looking at any other materials?
Oh, yeah, for sure.
That could be more cost-effective.
Definitely.
But still give you similar benefits.
Like what?
Like silver nanoparticles
Yeah.
or copper nanowires.
Interesting.
They're good conductors and might be better for large-scale production.
Yeah, that makes sense.
But they might not be as flexible and reliable as gold.
Especially at such a tiny scale.
Exactly.
So it's a trade-off.
Yeah, between cost and performance.
It makes you wonder if they could, like, combine materials.
Ooh.
Use gold for the really important connections.
Yeah.
And then something cheaper for the rest.
That's a really cool idea.
I bet researchers are already trying that.
It's all about finding that sweet spot.
Exactly.
So we've talked about micro displays.
Right.
But the article mentions that this gold microsphere technology could be useful for way more than just displays.
Like what?
Ooh, the possibilities are endless.
Okay, tell me more.
Okay, well, one thing that comes to mind is medical devices.
Medical devices, how so?
Imagine tiny biocompatible sensors that can track your health in real time.
Wow, that would be amazing.
All thanks to these tiny gold connections.
And they could be so small.
Right.
Flexible.
You could wear them like integrated into your clothes.
Wow.
Or even implanted under your skin.
Yeah, that's straight out of a sci-fi movie.
Oh, right.
Constantly monitoring your health.
Without even thinking about it.
And what about flexible electronics?
Oh, like...
But like bendable smartphones.
Oh, yeah.
Or wearable displays.
That would be so cool.
That could like mold to your body.
And what about electronic textiles?
Electronic textiles, like what?
Like clothes that can change color or pattern.
No way. So these gold things could make that happen.
They could be the key.
Wow.
To making all of this stuff a reality.
It's amazing to think about.
No.
Something so small.
Yeah.
Could have such a huge impact on the future.
It really shows you the power of science.
Totally.
This is like a perfect example.
Of what?
Of how a small discovery in material science can totally change so many different fields.
It's all about pushing the boundaries.
Right.
Finding new solutions to old problems.
But like you said earlier,
yeah,
cost could be a problem.
It's definitely a factor.
Are there any other potential downsides or limitations to this technology?
Well, as with any new technology,
there
are always challenges.
Like what?
Well, the article talks about how fast they can make these gold microsphere arrays.
Remember that 1 minute thing?
Yeah, that's super impressive.
But scaling that up?
Oh, yeah.
To mass production?
That's a whole other story.
It's one thing to make a few in the lab.
Right.
Making millions of them with perfect precision.
And doing it efficiently.
Exactly.
That's a whole different ballgame.
Any little mistake in those microspheres could cause the device to malfunction.
So they need to make sure the manufacturing process is not only fast, but also super reliable.
So more research is needed.
Absolutely.
Before we see this in our phones and stuff.
Definitely.
But the potential is huge.
Yeah, it is.
We've gone from struggling to connect tiny components.
I know, it's crazy.
To unlocking all these crazy possibilities like high-resolution displays, super sensitive medical devices, flexible electronics.
All thanks to these tiny gold spheres.
It's mind-blowing.
It really shows you how thinking small can lead to big results.
Who knows what other applications are out there?
I know, right?
Just waiting to be discovered.
Exciting times.
So for our listeners out there,
Why should they care about these tiny gold spheres?
That's a great question.
That's the big takeaway.
I think the big takeaway is that innovation can come from anywhere. We usually think of gold as like something luxurious for jewelry and stuff.
But who knew it could revolutionize technology?
Exactly.
It reminds you to never underestimate the power of scientific curiosity.
Totally.
And that even the smallest discoveries can change our lives.
All said.
And for everyone listening, this is just one example
of
the crazy breakthroughs happening every day.
In science and tech.
It's a world of constant discovery.
Absolutely.
And we're just getting started. Okay, so we've talked about the challenge of making electronics smaller and smaller. And we talked about this awesome solution.
With the gold microspheres.
Exactly.
Right.
We even touched on some of the challenges.
That's the cost of gold.
And some other possible solutions.
Using different materials.
It's been quite a journey.
It has been a really interesting deep dive.
As we wrap up,
I
want to leave you with something to think about.
Oh.
We talked about displays and medical devices.
and even flexible electronics.
Right.
What other applications can you imagine?
That's a good one.
What else could these microspheres be used for?
I don't know. What do you think?
I'm picturing tiny sensors.
Okay.
In
Like what?
Bridges.
To monitor their structural integrity.
Exactly. Or how about sensors?
Yeah.
In food packaging. To tell you if your food is still fresh.
That's a cool idea.
I know, right?
What about environmental sensors?
Ooh.
To detect pollution.
Oh, yeah.
With incredible accuracy.
What about tiny batteries?
Tiny batteries.
Yeah.
Like micro batteries.
That could store a ton of energy.
Like small devices.
Exactly.
That's pretty amazing.
It's like these microspheres
Yeah.
are a portal to a whole new world of possibilities.
And we're just scratching the surface.
Who knows what other amazing applications will be discovered as researchers keep working on this.
I know. It's really exciting.
It just goes to show that innovation can start from the smallest idea.
And in this case,
yeah,
that idea is golden.
Literally.
Right?
It's proof.
Of what?
That humans are super creative.
Yeah.
And that we never stop pushing limits.
Of what's possible.
Well said. A huge thank you to our expert today.
Oh, you're welcome.
For taking us on this deep dive into the world of gold microspheres.
It's been fun.
It really has.
Always happy to talk about this stuff.
And to everyone listening, we hope this deep dive has sparked your curiosity.
And got you thinking.
Maybe you'll be the one
to discover.
To come up with the next big thing.
For these tiny gold wonders.
Until next time.
Yeah.
Keep exploring.
Keep learning.
And keep questioning the world around you.
Stay curious, everyone.